All right, so I think it's 10:30 now. We can start at least by the introduction. Uh, I just want to make sure that my audio is working well and everybody see the screen. It's showing safety connection, machine safety 101 for supervisors. Thank you for people who's giving me thumb up. So if you can also use the chat, please, if you have questions, or if you have if you need to raise your hand for a question. So we're gonna try to answer most of the questions, all the questions definitely. If we have issue with the time, because we have 90 minutes, hour and a half for this presentation, definitely my contact is on the chat here, and it's gonna be sent to you on an email also, so you can reach me after for anything we missed or any question we were not able to answer today. So let's start with introducing myself. My name is Rafiq Zaki, and I'm working for Workplace Safety and Prevention Services, WSPS. WSPS is a firm that's working on health and safety. We are partially funded by the Ministry of Labor. We are provincial, serving Ontario. We have around 173,000 customers in Ontario, and we do consultation jobs, helping customers on health and safety things like training, consultation. I am specialized consultant on machine and robotic safety. I have colleagues specialized in hygiene, other colleagues specialized on ergonomics, general health and safety consultants. We do confined space. We do different things when it comes to occupational health and safety. I am a mechanical engineer and I'm licensed here in Ontario. I have experience on mining, 5 years, on oil field chemicals, petroleum chemicals, around 13 years. I was doing PSRs for a few years as well, working as a lead auditor on ISO certificates, 9001, 14001, and 18001. Now it's 45001. So this is a bit about myself. So we're gonna go through the slides today, and we're gonna talk about machine safety for supervisors. What machine safety means for supervisors. I know that I see here some people are admitting to the training. So if audio and screen working well, just please give me thumb up to make sure that technology is still working, or write on the chat, yes, everything is going well. Perfect. Okay. All right. So we're gonna talk today about machine guarding and supervisors and what does it mean. But before we start today, please take a minute on this survey, which is a requirement by the Ministry of Labor for any training we deliver. The Ministry of Labor just have some statistics for participants without any information, like it's completely confidential, and Ministry of Labor wants to see from where or what regions people attend, at what kind of trainings they attend. So if you can please scan this barcode on the screen or press on this link, it's gonna ask you for the function number. The function number of this job is 231734. So if you can enter this and answer the questions, it's gonna take a minute, then we can continue on the slides. So I'm gonna wait for a minute or so until you complete this, please. Thank you. All right. So we're gonna continue our slides. Some housekeeping things, we are using Teams here for this training. So just make sure that your computer audio is connected and your having your microphone is muted. So please feel free to use the chat here. If you have questions, and again, we're gonna try to answer all questions as much as we can. And your camera definitely will be like remain off, like, for the bandwidth and the connections. Like you can use your reactions here, sum up if like, any questions, or you can confirm something with it. We're not using polls here, and definitely you can use the meeting chat to write your questions or your comments, or if you want to add something during the training. Accessibility, definitely, like, you can turn on live captions by using the three dots on the top bar here, language and speech, and turn on the live captions, and you can use the full screen view if also you're interested to do so. Our goals here definitely, like, we're communicating, we talk, we connect, like, virtually with industrial peers. We get benefit, like, from each other. Everybody is a different location and have different experience. So please, like, if you need to add any comment that you feel like, it's beneficial to others, please do so. To facilitate best practice and attend from definitely your personal place. How WSPS can help on this. We have the free resources on WSPS.ca. We provide consultation, we provide training, and we have the WSRV Health and Safety Excellence Program. So these are some housekeeping, like, things that we want to mention. And now we're gonna begin our slides today about machine safety for supervisors. I keep an eye on the chat, and my colleagues here helping also on filtering the questions to me, to keep, like, an eye on the slides and the chat as well. So please feel free to write your questions on the chat. All right, I'm gonna start here with this quote. What does it mean supervisor, or what does it mean leader? So this quote saying, before you are a leader, success is about growing yourself. When you become a leader, success is about growing others. I like this quote actually because here you develop yourself to be qualified and competent supervisor or leader. Now, like, you begin to focus on, yes, yourself, developing yourself, but again, developing and growing others. So you are a leader, you have a team, and you're responsible for this team, for their tasks, for their safety, for their performance. So, and this is usually, we say, this is the difference between the leader and managers. Sorry, I think I have a glitch. Yeah, okay. All right, so what are the learning objectives for the slides today? We're gonna talk about machine safety, why machine safety is important, and why we need to talk today about machine safety. We're gonna discuss hazards, risks, and control. And please remember that these three words are very important three words because they are linked to each other. So when we talk about machine safety, we link these three words together: hazards, risks, and control. We're gonna discuss legislation. What the legislation requires from us when it comes to machine safety. And what does it mean, legislation? Legislation mean act, regulation, standards, codes. We every day hearing these: act, law, regulations, codes, standards. What are the differences between all of these? And what are the expectations when it comes to machine safety? We're gonna discuss also machine inspections and guardings, how we look at the machine and what things we look at the machine to see what kind of guarding we're expecting. You as a supervisor, what's your responsibility? And if you notice something, what should, like, you do? And also we're gonna discuss lockout, tagout. What's the difference between guarding, lock out, tag out, and when we do this and when we do that, and what are the next steps for you as a supervisor. So this is like, the objectives for today that we're gonna discuss. So let's start with machine safety. Why machine safety is important? Definitely safety is important because like it can cause injuries or it can cause fatalities for workers that work on these machines. So we see different types of injuries from fatalities on machines up to major injuries, minor injuries. So injury, every injury has a different, like, consequences on the workers. So that's why when we talk about machine, we talk about what could happen if. Usually we ask this question to ourselves. So you as a supervisor, when you talk to worker and you have a machine with moving parts or machine with hazards, you talk to the workers and ask this question to the worker. What if you put your hand here? What could happen? Probably it's a very slow machine. There is nothing could happen. Probably it's a huge machine with a huge hazard or huge rollers turning around, and it can pull the worker in or so. So usually we ask this question, what could happen? And this risk is different from a machine to other. So these are the injuries that could result from machines. What could happen? So why these injuries or these deaths could happen? Because sometimes workers has access to moving parts of the machine. Machine is exposed and there is no guarding, and the worker could put their hands. So as you see here on this photo, we have gears, we have chains, and any worker or anybody can put their hands and accident happen. So, and this is during machine operation. What about lockout, tag out? So during maintaining the machine, during repairing the machine, troubleshooting the machine, usually what lockout, tag out is expected. Why we need to lock out, tag out the machine? To make sure that the machine parts is not gonna, or the machine is not gonna operate during maintenance. So these are kind of causes during operation, during maintenance, during repair, sometimes due to inexperienced workers. So you have new employees that they are not experienced with this machine, or probably students or fresh graduates. Sometimes due to have a worker that very experienced with the machine. Like statistics sometimes showing that accidents most of the time happen with people or with workers that they are not experienced, they're fresh graduates, they are new, or very old people that working for this machine for many years and they have very good confidence that nothing happened before, nothing is gonna happen. So these are kind of causes or primary, let's say primary causes for injuries that happen on machines. All right. What assumptions we see on workplaces that sometimes lead to an injury for the so let's look at some of these assumptions. Just give me some bump when you hear this statement before, please. No one would ever do this. Anybody heard this before? See few thumb ups here. Yep. Okay. Doesn't make sense. We hear this a lot. We have something, and who's gonna do this? People see that there is moving parts here and there is a hazard there. Who's gonna put their hands here, right? What else? It has been like that for years and nothing happened. Okay, I see many thumbs up here. Okay, nothing happened. I'm working on this machine for 20 years and nothing happened. Why? And sometimes they make this statement as judgment if this risky or not. So sometimes when we sit with customers and do risk assessment, they say, no, we're not going to evaluate this as a high risk. It's working like this for 20 years and nothing happened. So we try to talk that nothing happened doesn't mean it's not a high risk, right? We cannot stop production. It's good for now. We cannot stop production. We need, okay, yeah, we hear this, right? Let's do the production now. We have specific batch. We have specific responsibility for production. Let's do production now. It will just take a second to do this. So sometimes clearing jams. We put our hands on a live machine to clear a jam, right? What's gonna happen if I clear a jam? It's gonna take a second to do this. All of these are assumptions that we as consultants in WSPS, when we help our customers, we hear all these assumptions after the accident happened. It will be fixed tomorrow. It will be okay for now. Okay? And yeah, exactly. And tomorrow, then we forget about it, right? It's common sense. Safety has no common sense, right? Sometimes we put a chain, like sometimes we see this, people put a chain and say it's not common sense when people see a chain like this, that they are gonna pass the chain and put their hands on the machine. But chain is not a proper guarding for a machine, right? Yeah, I see thumbs up here, right? It came like this, it must be safe. Yeah, a lot of thumb ups now, right? It come like this, it came like this. And I want to stop here on it came like this, because sometimes when we see some marks on the machines, we consider these machines are safe, especially CSA, CE mark, UL. These marks, it does not mean the machine is safe. That means the machine is built according to the technical standards. So when you have, and I'm going to give you an example for the conveyors. If we have conveyors coming for any end user, the conveyor has a CSA mark, but it has no guarding. What does that mean? The CSA mark on the conveyor mean it's built according to the ESA, the Electrical Safety Authority, the wiring, the technicality, all of this. It doesn't mean it has a guarding. And conveyors specifically comes on-shelf product. Anybody guess why the conveyors, it's an on-shelf product, comes with no guarding? If you want to write on the chat, you're thinking why conveyor specifically comes with no guarding to end users. So they sold by the supplier with no guarding. Any guesses? Usually conveyors, it is end users, exactly. It's end users installs. It depends on the end user application. So why the manufacturer is gonna put guarding on these conveyors and then you're gonna put it under a CNC machine, or you're gonna put it inside a robotic cell? It's a universal need to know exactly. It's a unique needs. So it's sold with no guarding. So when it come like this, we shouldn't assume that it is safe. We as end users need to make our job or our homework to make sure that the machine is safe and it is in compliance with the law requirements and the regulations. They are all like this. So all of these are assumptions that we hear usually after we have accidents or have near misses or something like this. So we actually don't go through this, and usually we proceed with the law and the act and the regulations requirements. We're gonna jump now to this rewarding. This rewarding is very important, not on the machine guarding only. It is for any kind of hazards. So ergo hazard, hygiene hazard, and slip, strips, falls, any kind of hazards or risks, we have three important words. What are these three important words? Hazard, risk, and control. What's the difference between hazard and risk? If you would like to write something on the chat, what do you think about what's the difference between hazard and risk? Any idea? Just throw some wording. Yes? Yeah, exactly. Yeah, thank you. Exactly. Exactly. This is all valid answers. Exactly. Hazard is the reason, the source. What could happen because I have like okay, let's take the example on machines. If I have moving parts, this is a hazard. If I have a danger, like on moving parts, like if I have gears, if I have chain, if I have sprockets, if I have rollers, belt, something like this is the hazard, moving parts. What is the risk? The risk, like you said, guys, here on the chat, the risk is the result that it's gonna come out of these hazards, like amputation, fatality, and we quantify this. Thank you for this comment as well. It's a quantified. What does it mean, quantifiable? That means we measure it. We measure the risk. We put this risk into numbers to see how bad the risk, how high the risk. And we use some parameters that we're going to look at today on measuring the risk and control how we remove this or how we eliminate this hazard or this risk. Okay? So, what kind of machine-related hazards here? We have cutting, we have drawing in, entanglement, stabbing, pressurized liquid, friction, shearing, crushing, impact. So all of these are kind of hazards that we can get from moving parts, right? But what else? We have also non-mechanical hazards, something like a machine that using chemicals for flammable material, explosions could happen, airborne substance, heat, noise, vibration, radiation, biological contamination. All of these are not mechanical or not moving parts hazards that could be on the machine. If we have an ergonomic issue, if like I have my worker or my operator or standing all the day doing repetitive movement um, or like carrying like boxes, heavy boxes, lifting, ergo stuff, all of these slip strips falls around the machine. If I have slip strips falls, if I have a forklift that working around the machine, and this forklift can hit the workers because it's a tiny space, something like this. Fire, explosions, pressure. If I have live cables that on the floor and I have liquids or water around the machine on the floor, all of these are kind of hazards. So what does that mean for you as a supervisor? Like, when you look at the machine and look at the workers that working on the machine, and do you look at this and say, what could happen if? This is very important one that we look at the hazard zone or like, the working area and identify what are the hazards, mechanical hazards and non-mechanical hazards around the machine. So these are kind of hazards that could provide from a machine. Okay, but what about risk? And usually we say risk or risk assessment because, as you said here on the chat, it is quantifiable. That means we can measure it. We have a process about risk assessment called RACE, recognize, assess, control, evaluate. So what we do first, we recognize the hazard. What is the hazard we have on this machine? Then we begin to assess the risk. We begin to measure the risk. How we measure the risk, we're gonna see. Why? Because we want to see what is the risk level, because based on this risk level, we begin to put the control or recommend the control in place. And as you said here on the chat as well, I see some people said remove risk, right? Remove risk. Remove risk mean we eliminate the risk or substitute the source of the hazard or put engineering controls. So the level of the control here comes from the risk level here. And then we evaluate the effectiveness. And this is very important to evaluate the effectiveness because sometimes we put the control in place and we still see that there is a still hazard or still risk in place. So we need to evaluate what kind of the effectiveness of the controls that we used in place. Okay? So recognize, assess, control, evaluate. Okay. When we assess machine guarding, we have a concept called MAC. What's MAC? MAC means if we have a moving parts and we have access, we're gonna have consequences. Okay, so this is the first question when you do risk assessment. Okay, do I have moving parts? Okay, the worker has access to these moving parts. What are the consequences that could and what could happen from this access? All right, so then this is the question: does this machine need a guard or not? What do you think? If you look at this photo, guys, just throw me your thoughts here. If I have seems like a press or something like this, and you see your workers put their hands and this RAM going up and down, what do you think? Does it require? I see few thumb ups here, right? Does it require guarding? Yes, right? So something like this, we're gonna begin to think what kind of guarding we can put here in a way that this worker is gonna keep doing their job. Sometimes we say, oh, I cannot do guarding here because the worker need access. But this is not the end of the story because every single machine we can suggest a guard to protect the worker without being an obstacle for the worker to do their jobs. We're gonna talk about this, but this is the concept we use. Do we have moving parts? Yes. Do we have access or the worker need access? Yes. If we answer this question, access by no, by the way, we can put this on an enclosure and that's it. We don't need to think about guarding. But these are the questions. Do I have moving parts? Yes. Do we have access? Yes. Okay, then we have consequences that we need control in place. How we do risk assessment and how we measure the risk. We measure the risk by using some parameters. These parameters, the main parameters is the severity of harm. What could happen if I put my hand here? Is it gonna be, it can cause a fatality to me, or it's gonna crush my hand, it's gonna cause a paper cut for me? No, it's very slow. We cannot it cannot do something like this. So this is the question. What is the severity? Okay. And what is the likelihood of the harm? Okay. And the likelihood comes from two things: the probability of something happen and can I avoid this from happening or not? Once we ask ourselves these questions. So definitely you as a supervisor, when you talk to your worker, you begin to measure the risk. Okay, what is the severity? And all these answers, this input, the best people to answer it, definitely the worker, because your worker that reporting to you is the one who's standing in front of the machine all the day and exposed to this. Once we measure this, it's gonna give us the risk level. And this is one of the matrices that we use to measure the risk. So the S is the severity level here. Exposure to hazard, E0 prevented, E1 is low exposure, E2 is high exposure, and the third parameter is avoidance of the hazard. Can I avoid this hazard or not? Can I pull my hand if something happened or not? Can I avoid to be in this area when the machine is working or not? And E1, E2, E3, and this is the matrix that give us the risk level. This is one of the matrices that we use on risk assessment. And this matrix is specifically used for machine guarding. It's taken from an ANSI standard, ANSI, American National Standard Institute. We have a similar one on the CSA standard. CSA standard stands for Canadian Standard Association. We're going to talk about CSA and ANSI on the coming slides. But this is one of the matrices that we use when we measure the risk. But why we measure the risk? We measure the risk here to begin to talk about the control. So for example, if I measured a risk and this risk is low, then I'm gonna put a specific control in place that doesn't have to have a high rating of safety integrity. So for example, if I hire electrician or integrator to put safety switch, you know, the safety switch that we have sometimes on the machine door. So if I hired a worker an integrator to put a safety switch on the machine, and this machine has a risk, and I measured the risk and I found the risk is low. Okay, so I'm good to go with category level, low category level of this safety switch, because this safety switch could have category 1, 2, 3, 4. It depends on the risk level. So what I want to say here is the control level should match the risk level. So, and we have specific standards again. So this is one of the standards that talking about talking about the level of the switches or the level of safety components that we have on the machine. All right. I think we have a question here, so let me pause. Okay, can you tell me specific ANSI? So as an equivalent standard where we got these metrics from? Yes, definitely. So the ANSI standard that have this matrix called for risk assessment, it's a RIA. Probably if you look at the screen here, we put a reference for it. ANSI, RIA, TR stand for Technical Report, R15306, 2016. So this is one of the standards, and we have a similar one also in CSA Z434, CSA standard Z434. We have another metric that we are using for risk assessment. The second question we have here, is the safety switch similar to an e-stop? This is a very good question. We're gonna talk about this. Safety switches and safety devices. It's coming on the slide, but definitely I'm gonna answer the question briefly. Safety switches, light curtains, safety device is a preventive devices that prevent accidents from happening. So the safety switch, if I open the machine door, it's gonna stop the machine immediately. E-stop is emergency device. So it is after the fact. So something happened, we hear screaming, somebody is running and pushing the e-stop to, so it's a complementary, we call this complementary safety device. But definitely emergency stop is not a safety device that prevents the machine from, prevent an accident to happen. So I hope this is answering the questions, but definitely we're gonna go into the details on the coming slides. Thank you, good questions. Now we're gonna jump into the third word is the control. So we talked about hazard, we talked about risk, we talked about risk assessment. Now we talk about control. We have something called hierarchy of control. What does it mean, hierarchy of control? Hierarchy of control means we need to go into this order when we talk about hazard. So if we have a hazard and we have a risk, then we're gonna begin to talk about control. If you hear your worker as a supervisor telling you, yes, I have this hazard here and I have a risk and I put gloves or I put eyeglasses, safety eyeglasses to protect my eyes, you're gonna say, no, we have something called hierarchy of control. PPE comes number 6 here. So let's talk from the start, from number 1. Did you try to eliminate the hazard from source or not? Or did we think about substitute the hazard or not? And I'm gonna give you a quick example for eliminate substitute. So if you have a saw, I'm gonna give a simple example. If you have a saw on your workplace and you're cutting pipes, okay, and you see this saw has a lot of hazards and cutting hazards. Let's think about eliminate the hazards. Let's think about talking to our supplier to send the pipes or the tubes with the right lengths. I don't need to use, so I eliminate now the hazard from the source. Substitute, let's give an example for substitute. If I'm using chemical and this chemical is a toxic chemical, I'm gonna substitute it with environmental friendly chemical or non-toxic chemical. So first step, we think about how we eliminate or substitute. We're gonna talk about, then we're gonna jump into engineering. Now I cannot bring the tubes or pipes in cut ready. Then I'm gonna use engineering controls. What kind of engineering controls? This is what we're gonna talk about today on the coming slides. Safety switch, safety light curtains, guarding around the machine, a lot of different engineering solutions to protect. The first 3 on the screen here, which is eliminate, substitute, engineering, this is what we call high-level controls. And the second 3 here are the low-level controls or the complementary ones. Awareness, something like training, something like beeps, lights, this kind of stuff, administrative audits, programs, procedures, and PPE comes to the end. Why we call this high level and these low levels? Because these are non-human controls. If I have a safety switch and I open the machine door, the machine will stop. Okay, so I don't have as a human an input on the control level. But here, if I have a SOP, a standard operating procedure, if I have training, if I have PPE, I am as a worker have the selection to go with them or not. So this is what we call hierarchy of control. And again, like, we look at the effectiveness that decrease this on the list. We're gonna jump to legislation, which is the next one here. This is okay. Yeah, I have a question. Yeah, we have a good question here on the is preventive maintenance needs on a machine considered an engineering control or admin control? This is a good question. The technical part of the maintenance is engineering control. Implementing the maintenance on a frequent basis and they have a program and procedure in place, it's admin control. So actually, it's a very good question. I got these questions before, but yeah, the preventive maintenance specifically has two parts. Technical part, which is engineering control, implementing part, which is the programs, the procedures, how frequent, auditing the programs that it's effective is the admin control. Thank you. It's a good question. All right. Jumping to legislation. So now we talked about why machine safety is important. We talked about hazards, risks, and controls. Now we're going to jump into legislation and what are the expectations from the legislation. When we say legislation, we have something called Internal Responsibility System, IRS. And I'm sure here if we have any members from Joint Health and Safety Committee, let's check. Do we have any certified members, Joint Health and Safety Committee here? Don't want to put anybody on spot, but okay. So probably you heard about IRS. IRS means, okay, IRS means Internal Responsibility System. We have four parties on any of firms. We have employer, which is the top management. What's their responsibility when it comes to machine safety or when it comes to any kind of hazards and risks. Then we have supervisors. This is the second party. We have workers. This is the third party. And we have the Joint Health and Safety Committee. This is the fourth party. When we talk about responsibilities, every party of these has their responsibility to fulfill when it comes to safety. So, employer, what's the responsibility for employers? To provide a safe environment, right? To have a safe, when it comes to specifically machine, to provide a safe machine, to provide the safety program, to train workers, to train supervisors, to hire competent supervisors. So all of these are responsibilities for employers when it comes to machine safety. And usually it comes from the top to bottom. Like you're gonna find the employer has a major responsibility because it's this is what we call like the deep pocket theory. Deep pocket theory is that the employer has like the upper hand. They are implement things. They fund the safety. So all of these are responsibilities for the employer or the top management. Second part here we're talking about is supervisor. What responsibilities for supervisors? Supervisors usually is the communicating point or the connection point between top management or employer and workers. And we usually say supervisor, you have a link for employers, like you're reporting things to the employer, you're asking the employer for things to make sure that the workers are safe and you have a safe environment, and at the same time you hear from workers and you implement safety measures with workers. So supervisors, they monitor the work, they make sure the workers are trained, are safe, and they inform workers about hazards. They hear from workers about the controls, what kind of controls should be in place to protect workers from injuries or to not to expose them to hazards. Third party are workers. Workers have big responsibility to make sure that they comply, they participate, they work with safe devices, safe equipment, safe procedures that the employer provided. and definitely joint health and safety committee or safety person or safety manager. They are monitors the system and identify the hazard and the recommendation and communicate this to the employer. They make sure that workers are working. So this is what we call the IRS. And usually when you have a near miss or you have something like this, or you have accidents, usually, and there is investigation, the ministry or the inspector like go through this sitting with employer, see where are the company from safety, sitting with supervisor and workers and see where is violation came from. So if we talk about the Green Book or the Occupational Health and Safety Act, it has some sections, okay? This is the act, has some sections that are talking about responsibilities for employer, supervisor, and workers. Then we have regulations, and we're gonna today, because we're talking about machine safety, we're gonna talk about Regulation 851. Regulation 851 is the regulation that talking about machine safety. And then we have a layer called standards. And as if you remember, we mentioned CSA, ANSI, ISO. These are the standards or the guidelines that make us meet the requirements here. So I'm gonna give a very quick, summary about this structure. The act and the regulation here are law. It's a mandatory, it's a shall language. Shall language mean it's a black and white, okay? Standards here, it is the guidelines to meet the requirements of the act and regulations, okay? So I'm gonna give a quick example about this. The act or the employer, section 25 says the employer must provide safe work environment, okay? Period, that's it. They didn't give more clarification, okay? Regulation 851 begin to go through this, telling you if you have exposed moving parts, you should put guarding in place, okay? Section 74 to 76 talking about if you have lockout, if you have maintenance or repairs, you have to do lockout, tag out, okay? So it begin to give more details, okay? But doesn't give you how to build the guarding. What's the measurement of the guarding? What's the specifications of the safety devices? How we do this? By using these standards to build the right control in place. So this is simplifying for what's the difference between act, regulations, and standards. Every time we go in this direction, it gives you more specific and more details. But you may ask me, what's the difference between act and regulations? You say both of them are law, are act, are mandatory. The difference that the act is a very high level, talking about any firm in Ontario. School, hospital, daycare, manufacturing, mining, any kind of business. But regulations, you have different regulations on the standard. You begin to select what kind of regulations is applicable based on your workplace. So if you're working in a hospital, you don't use 851 unless you have machines. If you work in construction, construction have specific regulation 213. If you have a confined space on your workplace, you can use regulation 632 and so on. So you select so the act is applicable for everything. The regulation you pick and select what kind of regulations applicable to your workplace. And definitely these standards are the guidelines. So these are very important standards if you want to take any note by these. So CSA Z432, this is the machine guarding standard, the Canadian machine guarding standard that we are using. CSA Z434 is the robot standard. CSA Z142 is the press standard, and CSA 460 is the lockout, tag out standard. This is important standard that we usually use when it comes to machine guarding. ANSI, the American standards, Okay, this is the robot one. This is R1506. If you remember, this is the matrix, the risk matrix that I opened few minutes ago. R1506. Sorry, this is the robot standard. And thank you, Marius, my colleague here, put on the chat a link to the R15306, which is the task-based risk assessment one. All right. And we definitely have guidelines for pre-start health safety review, MLI, from the Ministry of Labor. So these are like, you know, a summary about the act. So these slides are gonna like give you an idea about what I just mentioned now. Section 25 and 26 from the Act is talking about the employer responsibilities. When we talk about employer responsibilities, what are the employer responsibilities here as per 25? And this is again talking generally, not machine guarding specifically, but definitely it's applicable for machine guarding. Provide and maintain safe equipment, material, protective devices. Ensure safe measures are followed. Provide information, instruction, and supervision. Appoint competent supervisor. And we want to talk about competent supervisor. What does it mean, competent supervisor? Take every precaution reasonable in circumstances. This is 25-2H. 25-2H is very important one. And please remember 25-2H here, because you're going to see it also under supervisor. So I'm going to show you this also under supervisor responsibilities, and provide written instruction. Okay. So again, these are very important here. Can you put me on the chat your thinking about this statement? What does it mean, appoint competent supervisor? What does it mean, competent supervisor? What do you think? When we say competent supervisor, what does it mean, competent supervisor, for you? Competent in what? What they should be competent or qualified about? Yeah, exactly. Yes, exactly. They are aware by the process. They are aware they are aware of hazards, right? They need to make sure that they do their due diligence on protecting themselves, protecting the work environment, protecting the workers. They need to be trained. They know the machine, the process more than the worker that working on the machine, to make sure that they are training the worker and they are protecting the workers. All your answers are valid. So these are kind of responsibilities for employer. I think we have a question here. Okay. Yes, if you're buying, yeah, it's a good question. We have compliance, definitely. If it's built on the US, if it's built in Europe according to ISO, if it's built according to ANSI, definitely, because we say it's a harmonized. We have CSCA, we have ISO, and we have ANSI. These three standards are harmonized together. So if you have a machine that built in the US and it's coming to Canada, it is meeting the required. Definitely, if it meets the ANSI requirements, then it will meet the CSCA requirements. The only difference that I can advise you, if you're buying a machine outside Canada, to check the ESCA requirements, because ESCA, Electrical Safety Authority here in Canada, they have some specific requirements when it comes to the electrical panels and wire. All right, thank you for the question. Good question. So these are the responsibilities for the employer. Then we jump to section 27, talking about supervisor responsibilities. Supervisor responsibilities means you are You are as a supervisor, you are the the connection between the employer and workers. So you make sure as a competent supervisor, you ensure that your workers are safe. You ensure that they have their PPE. They are aware by the dangers and the potential hazards. They have their instructions, they are trained, and again, this is the General Duty 1, 272C, that just showed up on the employer one. Take every precaution reasonable in the circumstances. This is what we call the general duty clause. And you can find this, so you cannot say, oh, where is this on the green book saying that I have to do this? Once you notice or you begin to notice that there is a hazard and there is a risk, you are required to take every precaution reasonable on the circumstances, and this is what we call the due diligence of the competency. Workers has responsibilities to work in compliance with Act and regulations, to wear the equipment, the PPE, and to use the safety devices, to go with the instructions, not to bypass any safety devices, report hazards and report violations, and don't remove any protective devices prescribed by the employer and asked by the supervisor to follow, and don't operate in any way to endanger themselves. And as we know, workers have the right, and definitely you as a supervisor, you're also worker, they have the right to know to participate and to refuse unsafe work. And I stress on unsafe work. Don't refuse work, because I usually, when I ask this question, they say to me, refuse work. No, refuse unsafe work, not refuse work. So right to know what? Right to know about the process, how their machines working safely, how their machines are, what are the hazards on their machines, what are the risks and what controls they should do, or they should have to make sure that they are safe. Okay, and like, you know, definitely these are the fines and penalties that, like, you know, on the individual now can, like, you know, get up to 500,000 fine, a corporation up to 2 million, and corporation directors or officers up to 1.5 million. Before we jump to the next one, I just want to refer to this, a PSR. Just raise your hand or thumb up or just write on the chat if you are aware by anybody here aware by PSR or something called pre-start health and safety review. Okay. Okay, so we have few here. Okay, perfect. Thank you. PSR or pre-start health safety review is a requirement by the regulation. And when we say by the regulation, that means it is mandatory, it's a law. So any machine in Ontario, not machine, I'm gonna talk about machines only, but there is 8 items that require PSR according to the Green Book or according to the Regulation 851. But if we talk about machines only, what Section 7 on Regulation 851 talking about is any machine that has safety device on it. And when I say safety device, that means electronic or electrical piece that gonna stop the machine in case of in case, like, you know, the worker intrude the machine while it's working, then it will require a PSR. And when I say safety device, that does not mean emergency stop, because safety device is a protective equipment, proactive equipment to protect the worker, but emergency stop is after the fact. It's an emergency device. So if you have a machine with emergency stop, that does not require a PSR. PSR is an in-depth examination of a new or modified apparatus structure or protective element on a machine. It has to be completed by a professional engineer, and they have to provide you with a report stamped. This report either to have a letter of safety compliance or recommendations to bring the machine into compliance with the act and regulation requirements. So it's completed before the startup, carried by specific qualified persons, which are PEngis, professional engineers licensed in Ontario, and document the measures necessary for compliance. But if your machine is in compliance, that you're gonna get the letter of safety compliance type. And this is again under, if you look at the regulation 851. By the way, you can access regulation 851 online, and it's a free, like, you know, you can have a PDF from it, and this is under section 7. Perfect. Okay. So we're gonna talk about machine guarding. So regulation 851, we talked about the act now, section 25, 26, 27, 28. Now we're gonna jump into regulation, some sections from regulation 851. We talked about section 7, talking about pre-start health and safety review. Section 24, talking about an exposed moving part that can cause injury must be guarded by a guard to prevent access for moving part. For example, as you see here on the photo, fixed or interlock guard. Anybody know what's on the photo here? Just write on the chat, or anybody know what is this? Did you see this on your workplace? Do you have one of these? Yeah, safety gate interlock. Yes, interlock. It is interlock. And this is, as you see here, this interlock, if you open this door, it's gonna open the circuit and it's gonna stop the machine or whatever behind this guard. If you have a robot or something, sometimes this interlock has a lock on it, mechanical lock, that prevents the door to open when the machine is running. And some other times there is no mechanical lock and you can open, but once you open, the machine stop immediately. Okay, this section 24. What section 25 talking about in regulation 851? The in-running NIPs. Okay, so if you have an in-running NIP, you need to put guarding in the rotation direction, so there is no like hands entangled or pinched here. Section 26 talking about projectiles and flying material waste, like if you have a welding or if you have a robot and this robot can fly, things can fly, you have to put guarding around to make sure that it's not gonna endanger the workers. Section 27 talking about emergency stops, but it doesn't give you all the details about emergency stops. If it would just say it has to be easily accessible and identified. Some questions we get, do we have these, like, you know, shrouds okay around the e-stop? These shrouds are okay now. In the old standard, old version of the standard, these shrouds shouldn't be there, but in the new standard, they begin to allow these shrouds to make sure that it's not gonna pressed by mistake. But these shrouds must be built in a way that it does not protect the worker to push by their palm, their hand, or by their hand like this, sharp, or by. So it has to be easy accessible. So if I put these shrouds or these guards around in a way that it's preventing the worker to press it in case of emergency, then these shrouds are not suitable. So this is section 27. Section 33, talking about portion of conveyors or other moving machinery that are not visible from control station and where starting up may endanger any worker shall be equipped with automatic, and where starting up endanger one shall be equipped with automatic startup warning device. This is section 33. Section 74 and 276 of the regulation talking about lockout tag out. So hazards energy. If we have a hazards energy, that means it needs a lockout tag out and securing the stored energy as well. All right. Before I move to standards, I think we have questions here. Okay. If we take the guarding as an example, does it have come with a machine? have the additional consideration and okay, if we're talking about guarding, if you mean fixed guarding or fencing, this not trigger a pre-start health safety review. Okay, and the guarding, we're gonna talk about guarding now. The guarding should, if you're buying a machine with a guarding, that means or that we're gonna consider that the machine builder built this guarding according to the standards and it meets the requirements. So you as an end user, you need to look and assess if this guarding is built according to the requirements or not. But if you have fixed guarding or if you have like fencing or mesh or panels, that does not trigger PSR. PSR only for the cases that has a safety device, electrical, you have a safety circuit and you have something electrical or electronic that's gonna stop the machine. But emergency stop and fixed guarding does not require a PSR, but you still need to do assessment to make sure that it's built and it is preventing the worker to access the moving parts. We're gonna talk about this on the coming slides as well. All right, now we talked about the act and regulations. Now we're jumping to standards. Standards are the guidelines to meet the law requirements. Standards, I'm not gonna go through this in details, but as you see here, we have three types of standards. We have type A is the generic one. So back to your question here, we need to make sure that the guarding built according to one of these standards. CSZ 432, it has some guidelines, how high the guarding and how big so it has a lot of details. Type B, standard for safeguards. Type C, it's a machine-specific guard. So for example, type C, robot, press, but type A is for any machine, okay? We're gonna talk about machine inspection and guarding, and so this is an example for guarding, and this is what we call fixed guarding. Okay, sometimes we have interlocking guarding, sometimes we have adjustable guarding. What does it mean, fixed guarding? Fixed guarding is a very important thing. It has to be permanently. Permanently means by welding or by fasteners that require tools. Okay. What are the advantage? It is permanent. It is not expensive. It does not require PSR, but the disadvantage, every time you need to access, you're gonna need to lock out the machine to disassemble this and do your work. This is one type of the guarding. Another type is adjustable guard. Okay, something like this. You need to move the guard up and down around the blade to make sure that it's covering the blade. So you're adjusting it using tools as well to adjust it. Very important if we're using fixed guarding, and I think this is back to your question here. If we're using guarding, this is the first question we ask. Can a person reach through, around, over? If they can, then the guard is not adequate, okay? And that takes us to a table here on the CSCS standard Z432, the machine guarding standard, that give you a table with a relation here between the opening size and the horizontal distance to the hazard. So, and it gives you three options here, if it's a round opening, if it's a square opening or slotted opening, and what is the opening size. So I don't want to go very technical, like, you know, for the time, but this is a screenshot from the table coming from the CSCA Z432. Perimeter guarding, if you have few machines and if you have a robot and something like this on the photo, you have some openings, conveyors going in and out, how we build the perimeter guarding. It's very important thing that this perimeter guarding built according to the standard also requirements. We have dimensional requirements for this perimeter guarding. What are these dimensional requirements? The height of this fence shouldn't be less than 55 inch or 1.4 meter. And the opening to the ground here shouldn't exceed 7 inches. Okay? Again, all of these are from the standard. So it's very important you as a supervisor to make sure that when you have fencing or if you have perimeter guarding like this around machines, you make sure that it's built according to the standard requirements. We have like huge discussion about this on the standard, but this is like, you know, the high level requirements. What's whole body access? Whole body access is a very important one as well. You as a supervisor, you have a huge role about this. So what does it mean this? Sometimes we have a very good fencing and very good safety structure around the machine, but when a worker get inside, so anybody know what is this? Light curtains? Thumb up or in the chat. Do you have this in your place? Safety light curtains? Yeah, safety light curtains, it's a transmitter and it's receiver and there is beams. Once the worker pass through, the machine stop immediately. But what if this guy break this and get inside and their colleague from outside here, they didn't see them and they pressed reset for the safety device and the machine worked while this guy inside. We see a lot of accidents happen because of this, and that's why the CSA standard now included something whole body access. Whole body access, it's two things. If the opening on the guarding permits the entire body to enter the safeguard space, and there are some areas with the safeguard space can remain undetected. If this happened, that cause accidents, and the new standard now begin to put some measures to prevent this from happening. Something like if I get inside through the light curtain, I have a blank, I have to blank here the beam and put a lock so nobody is gonna operate the machine while inside. Or I put some sequential reset button inside so my colleague cannot reset the safety system from outside until I reset from inside, and so on. A lot of technical details that I don't want to go through them now, but this is, if you want to keep this in your mind, this is what we call whole body access. Whole body access. All right. When we know that the guard is inadequate, if I can, or if the worker can access around, under, through, over, and reach the hazard's motion, then my guard is inadequate. Okay, so please keep this, we call this the auto principle. Okay, around, under, through, or over. This is about the fixed guarding. So what we talked about fixed guarding is it has to be welded or with fasteners that require tools, and it has to have specific dimensions, specific openings to make sure that it's not allowing access. Okay. Now we're going to talk about interlock guarding. What's interlock guarding? Interlock guarding means that this guarding has a specific switch. Sometimes this is mechanical switch, like the ones that I talked about. Sometimes it's a magnet switch or non-contact switch. Sometimes it's coded, uncoded. We have different types of safety interlock switch. But in this phase, it began to trigger a PSR. Okay, because now we have a safety switch with. So this is the safety interlock switch, and opening this guard interrupts the operation of the equipment, preventing access to the hazard. Light curtain, sometimes we call it PSCD, present sensing device. Light curtain, again, once we interrupt the light curtain, the transmitter and receiver, the machine stop immediately. Okay? After you interrupt the light curtain, you need to go back to the panel and to the panel and reset the safety function to restart the machine. Okay, We have different types, and again, these different types are selected based on the risk level. As much the risk is high, as higher the type we need to put in place. The only piece that I want you to keep into consideration as well, that the distance of these light curtains, the distance from the hazard to the light curtain, is specified by equation that need to be calculated based on the stopping time. So sometimes if the stopping time is very low here, this light curtain need to move behind to make sure that if I cut this light curtain, the machine is gonna stop before I reach the motion. Safety scanners are the same idea like the light curtains, but the difference is the transmitter and receiver are built in this safety scanner. The good thing about this one, it's a programmable, reprogrammable. Sometimes we programmable in a way that we mark the floor. So for example, if somebody came on the yellow zone here, the machine is gonna slow down, but if somebody gets on the red zone here, the machine is gonna stop immediately. So this is the safety scanner, but again, this is safety device that's still triggering a PSR. So all of these are safety devices. Their level of protection exceeds the level of the protection of emergency stop. That's why we call this safety device. The other one is emergency, or the emergency stop is emergency device. Two-hand operator control. I don't know if anybody on the group here has two-hand operator control, but this is kind of, it needs two hands to energize the machine, and this is the least we use because it protects the hands only and protects the worker only who's using it, but doesn't protect others as well. So this is about machine guarding and the safeguarding that sometimes we're using. Now we're jumping to lockout tagout. Lockout tagout is required if the machine is not in operation. So any machine phase or machine life phase other than operation, the expectation is lockout tagout. Sometimes we cannot do lockout tagout. We need power to do troubleshooting. We need power to do something. I'm gonna clear jam. I don't need to lock out, tag out. This is another story that we do risk assessment for these tasks. And this is another story and another session that we can talk about later, probably, or if you have questions, you can contact me about this. But if we're not able to do lockout, tag out, and we do something called minor service, or something that I need power on it, we have to do something called risk assessment, and we use the risk metrics I showed to you to make sure that we have the right controls in place and we meet the risk reduction level, same level like lockout tagout. These are kind of hazards energy that we make sure that we control. And we make sure that it's not gonna hurt the worker during doing repair or maintenance. We have electrical, hydraulic, pneumatic, kinetic. Kinetic means something keep running after we disconnect the power. Potential, something hanging, something has a potential energy, thermal energy, radiation, chemical, and so on. So these are kind of different energy forms. It's very important to know that when we talk about lockout tagout, we talk about two things: the source, how we isolate the source that feeding the machine. So for example, if I have electrical, I have a switch, and this switch is lockable, I can put lock on it. If I have hydraulic, how I secure the hydraulic power unit, how I secure the compressor and close the valve and put a lock. And the second piece that's very important to consider is the stored energy. Keep in mind that when you cut the source to the machine, you still have stored energy inside the machine. So capacitor, if we have any electricians here, you know capacitors that store electrical energy. If you have hydraulic, what are the hoses and the piping storing? How I release this stored energy to make sure that it's not gonna hurt the worker during doing their tasks. So these are kind of stuff when we look at lockout tagout. We have a standard for lockout tagout, which is CSA Z460 460 2020. The last revision on 2020 have 7 steps for lockout tagout. These are the steps that we have to consider when we do our procedure. Prepare for shutdown, shut down the equipment, isolate equipment, control stored energy. This is the one that I just mentioned about, stored energy. Then apply lockout tagout device, verify isolation equipment, and every step of the first 5 need a verification. So we verify, and we in WSPS we help a lot of customers on doing these steps and on building placards for each machine specific. So what are the steps from 1 to whatever until bringing the machine to 0 energy state. So this is, and I know, like, a lot of our firms and customers as well are doing this. All right, I think we still have like 10 minutes, so let's discuss on these 10 minutes what's next now. What do you think after, like, I know I threw a lot of information for you on a very short time, 90 minutes, but what does that mean for you as a supervisor? When you think about this, what do you think? What do you think? What do you or should you do to protect your workers and your team from machines and hazards and risks? Think about this. Like, what tasks you're gonna begin to look after, like, you hear this. Are you gonna observe the team, how they are working on machines? Do you understand the hazards? Do you have risk assessments? Exactly. Thank you for, like, these comments. This is great comments. Do you have communications? Do you have your worker participations? Do you audit or monitor the process for your workers on machines? How you engage your workers? So all of these kind of questions that you may think about. What are the challenges you face relating to managing machine safety and guarding? Do you have specific challenges? Do you have, like, the input from worker? Do you have, like, the support from employer to identify the proper guarding? CSA Z432 is a great source for risk assessment, risk reduction, and guarding as well. So it is a document that you can use. Lockout tagout CSA Z460 2020 is a great source also for hazards energy, control hazards energy, and how effectively you manage control of hazards. And I think we have a good question here on a good time. Probably I'm gonna answer this, like, and quickly. Should we have supervisor verify the lockout tagout done right, or leave it to worker training, trust it? It's very important that not supervisor only, the employer, actually, the employer puts the right steps for lockout tagout. I'm gonna, like, in a couple of minutes describe this quickly. Lockout tagout, we have 2 things related to lockout tagout. We have the program, and this program or procedure describe how we do things, okay? How we do the lockout tagout. And we have something else called, and this program should be according to the CSA Z460, this standard that I just showed on the screen. But we have something else called lockout tagout machine specific procedure, or placard. Sometimes we call it machine lockout tagout placard. That it's different from a machine to another machine, and it has specific steps. What should be done first, then what should we continue, how we continue until bringing machine to 0 energy state. And every step of this placard has to be verified according to the steps. So these 2 has to be built right by the employer, and definitely supervised by the supervisor. And if you as a supervisor think that no, this is not adequate, we still have energy here or energy there, probably you can consult if you can do it yourself, or if you can consult engineering or any third party in WSPS, we're doing this as well. We help our customers on building machine-specific placards as well. So definitely, but it's very important to make sure that we are doing the lockout, tag out on the right way, because when you tell the worker that it's safe now to go and do your repairs and you still have energy inside, this is worse than if you tell the worker, watch out, you have something. So you give the worker self-confident now, yeah, it's locked out, tag out, go ahead. So it's very important to make sure that the procedure is going on the right direction. So this is part probably sometimes some challenges that related to lockout, tag out, right? PSRs, this is a question that probably you're going to ask yourself. Do I have a PSR? Do I need to do PSR? Is this a CSCA approved? Does it mean require a PSR or not? Again, in WSPS, we can help you on training for a PSR. We don't do PSRs, but we do training for PSR engineers and PSR and the companies that ask about PSR. But due to, we are like, WSPS has engineers and professional engineers, and we can do PSRs, but due to sometimes like conflict with the Ministry of Labor or something like this, we cannot do PSR, but we can deliver only the training for PSR engineers. And I think we came to the end here. These are some resources that WSPS also will share with you, I think, on an email after this training. These are some resources that we help our customer with. CSCZ 432 training, it's 1 day. 434 for robots, 1 day. Half day for managing machine safety, half day for managing robot safety. We deliver training for PSR half day as well. Lockout, tag out essential, risk assessment for machinery, for minor service. And so I think we came here to the end. So let me check if we have more questions. For handoff from one person to another, for example, a worker to a maintenance person, should the maintenance person verify? Yes, definitely. Definitely from one person to another person, lockout, tag out is a unique. So everybody has their locks. If so, there is no switching keys. Everybody. So if I have a maintenance person doing a job, so this maintenance person switching with another person on another shift. So the first person is removing their locks, and the new person putting their locks. But it's not, they are not switching, or they are not verify each other. It is verified one time. Once it is, once they proceed with the placard, 1, 2, 3, 4, until bringing machine to 0 energy, then switching the locks, it is an admin thing only, which is mentioned on the program itself. So again, it has a one for administrative, one for the technical one. All right, thank you for the questions, and thank you everybody for your time. My contact is here on the chat, and you're gonna receive it on an email from WSPS as well. So please feel free if you have more questions. I try to answer most of the questions during the session, but respecting for everybody time, probably if you have any more questions, please feel free to contact me. Thank you, everybody.